Welcome to another GCBASIC tutorial. This is for the 16F175xx chip family, and that's a whole series of chips that start with 16F175. This is part 4, sequence the LEDs. So what we're going to do is we're going to sequence the LEDs based upon the result of a reading of the ADC. Now, like and subscribe, please. That's essential. I'm in this for the likes and subscribe, so please like and subscribe. So on tutorial 4, we're building upon what we've done previously. So previously we've set up the hardware, we've made the LEDs flash, we know that we can make the LEDs represent the value of an ADC, and now we're going to sequence the LEDs with a delay using another value from the ADC. Fantastic. So I'm assuming that you've installed the software, you have your programmer, you can talk to this new chip, and you've got 4 LEDs, and you have a pot. So if I look at my setup here, here's my setup. I've got the new microcontroller sitting here, 175xx I'm using, quite a large one. I've got a potentiometer sitting here and 4 LEDs. And I've got the LEDs connected via suitable resistors. I will show you the circuit for the potentiometer in a moment. If I rotate that, that's where we left it in the previous tutorial. It represents the value of 0 to 255. So let me go back into the presentation. So that's what I've got it connected to. I've got it connected the ADC on R80. The LEDs are on RC0 to RC3. And I've got a small circuit which is shown here on the right hand side. RA0 is protected by a 1K resistor down to 0V by a small capacitor, and then the variable resistor is sitting here, and that's the potentiometer. Another way of looking at this is, and you'll see that in the program itself, I've got this little diagram. So I've got port A here. I've got the ADC on 0. Port C, I've got the 4 LEDs. And this sort of documentation helps you understand what you're trying to do with these in any programming language. So I've got a prototype board, I power it from 5 volts, I've got my programmer hooked up, and I've got these LEDs and resistors. So let's have a quick look at time. We touched on this before. Let's peel this back a bit more. So we can actually use time in slightly different, we're going to use it in a slightly different way because we're going to pass it a variable, because we can use time, a delay. It can be microseconds, or 10 microseconds, or milliseconds, or 10 milliseconds, or seconds, minutes, or hours. So what you do is you go wait, and it's always the command wait, and then what the delay is, and then the unit of delay. But what we're going to do, rather than saying wait 1 millisecond, we're going to put a variable in there. We're going to use the return value from the ADC. So we've seen this before. ADC, GCBASIC completes the initialization. We're going to take the ADC value and store that in a variable. And we're actually going to use a greater, what's the right word here? Greater granularity in the read of the ADC, because we're going to use a 12-bit read. Before we did it with a 0 to 255, or that's an 8-bit read. So we're going to get a value between 0 and 4095 back. Then we're going to use that variable to wait for a time period and then set the LEDs and do it all again. What does that look like in terms of a flowchart? Looks like this. So we're going to start, initialize the chip. Great. We're going to set the first LED. Then we're going to use the 12-bit ADC read. We're going to use that for our delay. We're going to rotate the value. We're going to rotate the LEDs. So I'll show you how that works. And if one or two things happens, it will either continue to rotate by going, and I'll explain overflow in a moment. it will go around here until it does overflow. I'll explain overflow in a sec. And then it will come back and then reset the first and then go and do it all again. So it's a very simple flow. So let's look at this thing called rotate, and I mentioned it in here. Did it overflow? Well, overflow uses a thing called carry, and you can test whether it carries. Now, what does that all mean? Well, what it means is it's a diagram like this. If we put a bit value into a variable or into a port, and we rotate it. We can rotate it left or right. And in this one, diagrammatically, I'm moving it to the right. We might use left in the program, but this is for the purposes of explanation. So if I set a file register, be that a piece of RAM or a port, and I go this particular start value is 1, it will set it to high. If I then rotate, it will actually move that to the right, so it will go from the .4 position to the .3 position. If I rotate it again, it will move along, and then it will move along. And what happens next is, when it goes the next rotation, it puts it in a particular register to say that it happened. And we can test for that. And because we can test for it, and it's called the carry bit, we can restart the process and go back and do it all again. So we can test a thing that's called carry. And if you look in the top right-hand corner of this diagram, you can see that's the first byte, then the next, then the next, then the next. Where does it go? It goes into the carry. It doesn't get lost, that bit. You can test against the carry. So what we're going to do is test that carry, and in GCBASIC, in all the chips we support, you just say C equals. So if C equals 1, then the overflow has occurred. You can clear the carry by saying you can clear the carry. That's easily done. But if you say C, it means the carry flag. We're also going to use something called scale, and we're going to transform the value that we read in the ADC to a specific scale. So we're going to transform the value of 0 to 4095 to 50 to 1000, and there's a good reason for doing that. Is that 4 seconds on a set of LEDs looks rubbish, and this just works right. And you can play with that in your own time, but we're going to take the ADC value, the 12-bit value that relates from 0 to 4095, and we're going to transform that into 50 to 1000. And the command to do that is called scale. So let's look at what we're going to do. We're going to read the ADC. We're going to use a word variable to store that value. Some simple logic, rotate, a bit of bitwise masking, and then use this scale. Really quite simple. Right, let's have a look what we've got here. Let's look at my desktop. If I press the Windows key, type in GCS, that will open up GCStudio. Once I'm into GCStudio, I get this. I can then select my recents here, and if I hover over that, you can see that's the file location: GCStudio, GCBASIC demos, vendor boards, and then you can carry on GCBASIC demo board, and then there are the chip range demonstrations for this particular chip. So if we open that, and it's opened up the IDE. On the left, this window on the left, all the files are available, and this is the program on the right. So if we shut down all the programs, and we can get rid of the list of programs by pressing Control B, or we can select the Explorer at the top. We've just got an empty IDE. Let's have a look at the programs we're looking for. We're looking at 060 variable rotate the LEDs. Click on that and it opens up the program. Now what you can also do in the IDE here, you can press Control F and it brings up a little search dialog. And that little search dialog shown at the top of the screen now, if you type in GCB, and then this inverted triangle here, you press that, it will filter and get rid of all the other assembly files that have been used. So now we've just got, we had there for a moment, just the GCB files. Look, there they are. All the GCB files are sitting there. So just a quick trick there. Control F whilst in that dialog, and then you only see the source files. I'm going to shut that window by pressing Control B. So this is my program I want to walk through. Well, why don't we look at it? We'll program it to start with, and then we'll walk the code. So there's my board. I'm going to press the top right-hand icon, H and F. And what does that do? It makes the hex and flashes the chip. So if I press that button there, it fires up the bottom window, compiles the program, already done it, and now it's programming it. And so what's happening now is we're actually in the program, and we can see already that the LEDs are rotating. So this carry process and this moving of one bit to the next bit must already be occurring. If I take my adjuster and I rotate that, that's 50 milliseconds in between each LED transition, and 1 second, which is fully on. So it's done something's doing the transformation. So let's look at the code. I'll just turn that off. There we go. Let's look at the code. So here we specify the chip option explicit, which means we have to define our variables, which is quite useful, and that's a nice protection. We saw the next set of constants here in the previous demonstration. I just define an LED port, a constant, which relates to the port C, lat C. I've defined a constant called potentiometer for port A. And then I set these particular directions. I set a dir for direction. RC0 is output because that's an LED, through to RC3, that's also an output. And I go potentiometer as an input, which is great. So how do we initialize this thing? Well, I create another constant. It's really a macro. It's an LED, I've called it LED state macro because I'm trying to show you here that you can set RC0, RC1, RC2 to 0, and then RC3 to 1, all in one macro. You've got a colon, which essentially means new line of code, but you can do it in a single line like that, and now we can reuse that whenever we need to. Now, I also defined another constant called a mask. And I said I was going to do bit masking, so this is a bit mask, and it's a bit mask that says essentially for every bit of the bits 0, 1, 2, and 3, they're set to 1, and I'm going to use that mask in a moment to strip off all the other bits. I'll explain to that when we get there. So first thing I do is I call the LED state macro, which sets these 4 states. 3 are set to off, 1 is set to on. Wait for 1 second. I then declare my ADC variable. It's a word this time. Previously, we'd used a byte. Well, a byte's not big enough for this value, so we need to put it into a bigger value, into a bigger type, and that type is a word. Then we've got this do loop. We've seen these loops before. If I just do that for you, it's a do loop, so it's going to do this forever. I'll zoom back in. So here we go. Read AD12, and I've selected ANA0, ANA0, and that is on port, the port that we need, and they are specified quite clearly, and we discuss those by looking at PIC info, the software called PIC info, and that would help you analyze what they're called. Read AD12 and put it into a variable called ADC val. Fantastic. We've now got the value tucked away. What we're now going to do is scale that value and put it back into ADC value. So scale the value that could be between 0 and 4095, between 0 and 495, and I want to scale it to 50 to 1000. And that's all you have to do. The rest of it is all done by the compiler. So how is this delay different? Well, I've said wait ADC val milliseconds. So the delay will always be proportional to the ADC value. That's what causes that small delay. The delay changes when I change the position of the potentiometer. Now, I'm now going to rotate the LEDs. Well, I spoke about what C is. Well, I'm going to set C off. And C is the carry flag. So set the carry flag off. You could set that to 0. C equals 0 is the same thing. Set C off. Then I rotate the LED port, the whole of the LED port, because that's set to port 0, to the right. If it has carried, then it will recall the LED state macro, and it will clear out this port. I'll explain that in a moment. Now, if it doesn't equal 0, it just rotates around and then does the do loop and does it again. So it repeats forever. But if the carry does occur, it resets the LEDs to 0, 0, 0, 0, 1. Is that correct? Yeah. So that's this value here. So essentially, the fourth LED, 1, 2, 3, fourth LED is turned on. But what can happen is that we need to know what the state of the LED port is. So we just throw away the other bits. And the way we throw away the other bits is using this mask. We say AND, logical AND. LED port, whatever the value is, and the mask. And our mask is, if you remember, it's 4 zeros and a 1 and a 1, 1, 1, meaning 15. So what we're seeing here all the time is it's managing the LED port by masking it and stripping off any spurious values that came through. That way, we always have and only have addressing of the 4 LEDs. And that's it. If I turn the camera back on, it all sort of makes sense. It's coming around. I'll put it on the slowest to see if I can talk to it. Slow, slow, slow. What's that fast? Oh, 1 potentiometer. So LED comes on. It's read by that point, it's already read the ADC. It's already scaled it. The wait occurs. The wait occurs when the LED is sitting there. Then it does the next rotation. It checks that the carry, if the carry has not been set, it carries on and sets the next LED. If the carry has been set, it moves it back to the beginning, which would turn the blue LED back on in reality. Very simple. But what we've seen is a lot of new commands and a lot of capabilities being exposed in this very simple demonstration. Back to my PowerPoint. So that's all I wanted to show in this tutorial. Work through it at your own pace, nice and slowly, using the source code as you wish. So the next video and next tutorial will be using an input to set the state of the LEDs, which is an input, a digital input. So we're moving away from analog services into digital inputs, which is great. So enjoy.